everyone, I hope you are doing good. So today we will take a new DSA question in this DSA series, and this is the question which got recently asked in one of the interviews. That is the reason I am taking here. So we have to construct a binary tree, right? So keep in mind this is a binary tree, not binary search tree, right? And from the in order and post order. So we will get the data of the in order and post order of that tree. And using that in order and post order, we have to construct a binary tree. See here, given in order and post order traversals of a binary tree having n nodes in the array in order and post order. Two arrays will be given. Our task is to construct a unique binary tree from these traversals and return its root. Right? We have to construct the binary tree using the in order and post order data, and we have to return the root of that tree. So this driver code will print the traversal of the constructed tree, so that is we can ignore. And the in order and post order traversals contains unique values, and every value presents in the post order traversals is also found in the in order traversal. So basically it is saying, yeah, and it is true. We have a tree. If either we print in order, post order, pre order, all the values must be there in all the arrays. So let's take this example. So here one in order data is given. See, this is the in order array, and one post order array is given. This is the post order array. We have to construct this tree using this in order and post order data, correct? And then driver code will print the pre-order of the given tree, the constructed tree basically, correct? So I hope you are clear with this one. So let's take the another example. So see this one. So here in order is given, post order is given. So we have constructed this tree, and we have returned the root value or root address, right, to the driver code, and then driver code will print the pre-order of this constructed tree, right? And I hope, I'm assuming that you know very well about the pre-order, in order, and post order, because these three tree traversal techniques will be used in my approach, right? And that is what is asked here, right? So quickly, if you don't know, then I have already uploaded the video in detail video. How can we basically find the pre-order, post order, or like level order, in order traversal techniques, right? I have already discussed in detail, right, with multiple examples and code. So you can go through those videos so that you will be clear with these techniques, right? So let me quickly show you here. So basically what we have to do, so in order, what we do, so here we just draw the line below here, this one, and we start from top, and we see here this is encountering, so we print 9 here. Then we go down and we encounter 5, so we are printing 5. Then we go up, and here, right, we are crossing this 2, so we are printing 2, right? In means between left and right, and we just draw the downward line, correct? And we go down here, right, down, and we encounter here 3, so we are printing 3. And then we go up here and we are encountering 4, right, and nothing is there, and we go back to the top. So this is the in order, that is what is printing here. Now coming to the post order. So for post order, we draw the line right side, basically this one, correct? And we do the same thing. We start from the top here, left, go down, nothing is there, go up here, 5 is encountered, so 5 we are printing. Then here 9 is encountered, so 9 is getting printed here. Then 2, nothing is there. 4, 3, nothing, no, 3 is encountered here, right? So we are printing 3, and go up, 4 is encountered, so we are printing 4, and then 2, so 2 is getting printed here, right? So this is how we are getting the post order data, correct? Now talking about the pre-order here. So for pre-order, we draw the line basically left side, right, for pre-order. So now we start from the top. So yes, 2 is getting printed here first, right? Then 9 is getting printed, then 5 is encountering, so 5 is getting printed here. Then we go up, nothing is there, no, right? Go down here, 4 is getting printed, and this 3 is getting printed, and go right and go up, nothing is there, and right, coming back to the top of the tree, right? So this is the output which is in pre-order, right? So I hope you are clear with this pre, post, and in order traversal, right? For post order, we have to draw the line right side, right? For pre-order, we have to draw the line left side, and for in order, we have to draw the line of the downwards, basically in between left and right. That is what you have to do. Now from this, now you are clear what we can say before coming to the solution. What is given here? So in order is here, in order is 9, 5, 2, 3 and 4, correct. Post order is 5, 9, 3, 4 and 2, 2, 9, 5, 4 and 3, right. So now you can say, now we can see here by seeing this post and pre-order, right. So in pre-order we encountered root first, right. So this must be your root. The starting element of the pre-order would be your root of the tree. That is what we can say. And by seeing the post order, right, so by seeing the post order, the last element of the post order would be your root. This would be your root. So this info will be used in our solution. That is why I am explaining here, right. So now I hope you are clear. The first element of the pre-order data would be your root, and the last element of the post order data would be your root, right. So now here we have the in order and the post order. We do not have the pre-order. So what we can do, we can basically ignore this pre-order data. Now using by seeing here, what we can say, we have in order and post order. So the last element of the post order would be your root of the tree. That is what we need, right. And now using this post order data, this root data, what we can decide what would be your left and what would be your right subtree, right. And how we can do that, because see here, right, here in the tree, when how we find the in order, we draw the line downwards between left and right, right. And so this would be always, we traverse from here, go up, right, and here, and we encounter this one. So this part would be your left subtree, and after crossing this data, this root, that part would be your right subtree, right. This would be your right, correct, and this would be your left, right. So what we can say now here, uh, what we can say now, that we will find this root data into the in order array, right. So here if we go, and this is our basically root value. So now what we can say, this part is the left part and this part would be right part of the subtree, right. We can verify here with this example here. 9 and 5 is coming into the left part, and 4 and 3 is coming into the right part, right. So this info we will use. What let me repeat it again. Here, right. So the last element of the post order would be your root. This would be your root, right. We will find this root into this in order data. Why? Because we have to decide what would be your left subtree and what would be your right subtree, right. So we find, and we found this is our root index, basically, right. 0, 1, 2, 3 and 4, correct. So second would be your root index. So now 9 and 5, the left part would be this left of this the left sub array of this array given in order array would be your left subtree part, and the right sub array after this root index, right, that would be your right subtree, you can say. That is what, uh, right. I hope it is clear. Till now we are clear. So now coming back to my solution here, so what I will do, I will basically recursively construct the left subtree and the right subtree till we get the zero node. Zero node, it means the null value, correct. So that is what I will do here. So let me basically write the code here. So we will have the node pointer, then we will have build tree, that is that would be your function name. We will get the in order array, correct. In order array we are getting post order array. So post order array, and we will get the size here. N would be the size of the tree, or you can say the size of the array, basically, correct. So now what we will do here, what I have explained. So first we will check if n is 0, right. In recursive functions, what we had the base condition to terminate the recursive calls. So that is what we are adding here. correct? So if n is 0, then what we will say, return null, right? If n is not 0, something is there in the Inorder and Postorder. So first we will find the basically root value, right? So for example, integer val is equals to Postorder n minus 1. That is what I have explained. The last element of the Postorder would be your root, correct? I hope you remember this one, right? So n minus 1 would be the last element of the Postorder array. So that would be your root value, correct? Now construct the root here. Now node pointer root new node, and here we will pass the value. That is, we have created the root node here, right? We have created the root node here, correct? I hope you are clear now. Now we have to find the left part of the subtree, right, and right part of the subtree. So for that, what I can do, I have to find the index in the Inorder array, right? So what can I do? Integer index is equals to, we can say find. Here I will pass the Inorder array and the value, right? And this find index will give me the, basically we can write a sub function here that will give me the index of this value. Value is here, that is 2. So this will, right, 0, 1, 2, 3 and 4, these are the index. So I will get this 2 here, the second index, where I found the value of the root of this tree, correct? And here I got the index, right? I got the root node. Now what I will do, I will now basically build a left subpart and right subpart recursively. So what I will say here, I will call the recursive calls node pointer left subtree is equals to build tree, and here I will pass the array of Inorder, Postorder. Don't worry, I will show you the C++ code also, and this is also in C++, and here I will pass the index here. Why I am passing index here? See, because I got the index as a 2 here, I will get 2, right? And the size of the left subtree would be 2, because index starts from 0. So 0, 1 and 2. So we are not considering 2 here, we are considering 0 and 1, because we are passing as a size. This index we are passing as a size. See here, idx we are passing and we are taking as n, and n we are considering the size of the array, correct? So we have 2 elements here, this one 2 elements only, and we do the same for the right subtree, right, bt, and here for right subtree we pass Inorder plus, right, because Inorder starts from 0 plus n, idx plus 1, right? We have to ignore this root value also. So 2 plus 3, 1, that is 3. So 0, 1, 2, 3. So the Postorder part, right, the Postorder part starts from here, correct, from third index. So that is why I am doing Inorder plus index plus 1, comma, then I will add here for Postorder. So for Postorder also, what we have to do for Postorder, we have to ignore 5 and 9, because 5 and 9 are the part of the left subtree, right, and we are calculating for the right subtree. So in this time we do not have to add 1, we directly say Postorder plus idx, right, here. And for n, now we have to give the size. So size would be n minus index, right, minus 1. Why minus 1? Because here the size is initially 5, right, index we got is 2 and minus 1, so now we get is basically 2. So right sub array size would be 2. That is how we are calculating here, n minus index minus 1, right? And then after this we have constructed the left subtree, right subtree. Now we can add this into the left and right of the this root node, whatever we have created here. So what we can say, root arrow left is equals to LST and root arrow right is equals to RST, right? And then we can return basically root here recursively. So this is the algorithm, right? This is my solution, how we are basically constructing the binary tree using the Inorder and Postorder. So let me explain it here itself. First we are finding the root node, that is 2, right? And then we are finding here, right, a value of the basically root, right? And we are creating a node, root node here. Then we are finding the index of that value inside the Inorder array, so that we can decide what would be the left part and what would be your right part here, correct? And that index we got here, so that index would be 2 here. So let me clear this one. So here in post order we found this is our root, and then the index of this one is here, this one, that is 2, 0, 1, 2, 3 and 4, correct? So this is 2. Now from here we will construct the left subtree and right subtree. So what would be the left part here? So this will come as a left subtree and this will go for the right subtree, correct? And so here we will construct the left subtree here. So in order, post order, we will pass this array complete we pass, and the size here would be 2 only, correct? So because see left side only 2 elements are there, so the size would be 2. That is why we are passing the index here. For right subtree, constructing the right subtree, what we need, basically we have to pass this one. So that is why we have to basically increase or this one, the base index of this in order array. So that is why what we are doing here, in order plus index plus 1, right? So what we are doing here for right subtree, so this is our index, right? And the index value is 2, 0, 1, 2, 3 and 4, correct? And so 0 plus 2, that is 2, right? What we are doing, 0 plus 2 plus 1, that is 3. So from third index it should start the right, the in order array for right subtree, it should start from third index, because this part is for the right subtree. That is what we are doing here. And for post order array, post plus index, right? So for post order, what we should do, for post order, this is your root, right? And 2 elements, these 2 are part of the left subtree, so we should ignore only these 2, right? So here post plus index, so the post order array should start from the 0 plus 2, that is 2, 0, 1, 2, right? So this index from here it should start, because we have to ignore this last one. So that is why what we are doing here, size we are passing is n minus index minus 1. So n is here 5, right? N is 5, index is 2, that is what we got, n minus 1, right? So now we get 2 only. So the array is having 3 elements, but the size we are passing for the post order right subtree is 2 only, correct? So 3, 4, 2, so last element will automatically be ignored here. That is why we are constructing left subtree and right subtree. And then once we are done with left and right subtree, then what we can do, we have already root. So for root arrow left, we add to the left subtree, and for right subtree, we will add to the root arrow right, and then we will return the root here. I hope it is clear. Let me show you the C++ code for this one. So here you can see the code. Basically, so we got the inorder, vector of inorder and post order. So I have converted it into the row array of inorder and post order, right, using dot data, correct? And size of the because both the arrays would be same size, right, will have the same size, and each and every element of inorder would be there in the post order, right? That is what, because this is the using the same tree, correct? So that is n we are passing here, correct? And now going back to our main function, right? So here we got in order, post order and n. So we are checking for n here. If n is 0, then we are returning null, correct? Base case. And then we are here finding the root index. So for this I have added the separate function, right? But here you can do the same thing here itself, right? So here in order, post n minus 1, this would be your root, that is what we know, from the post order array, from the post order technique, right? The last element of the post order array would be your root, correct? So we are calculating a root index. So we have the root index. We have created the root node here, correct? And here we are building the left subtree, build tree in order, post order and root index. That is what we are passing here. And for right subtree, we are building right subtree. So in root index plus 1, right? Because we have to ignore the left part. That is why we are doing this one, correct? That is what I have explained already. And here post plus root index only, because we have to ignore the left part, right? And the last element, we are not adding here 1, because the last element will automatically be ignored, as we are passing the size of this array would be n minus root index minus 1 here. That is how from the post order, one element will be, the last element would be ignored automatically. And then the root arrow left and root arrow right. So we are basically assigning this left subtree to the root arrow left and right subtree to the root arrow right, and then we are returning the root, right? So recursively it will basically go and construct the or complete tree, right? So I hope it is clear. If you know the tree traversal techniques, right? If you are well versed with the tree traversal techniques in order, pre-order, post order, then this is very easy for you. So let me know if you have any doubt, query, comment below the video. I will try to reply there itself, or I will address that issue into the next video. Thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.